Welcome to Facts for Sleep, where science drifts softly, like a dream. Tonight, we'll explore 100 facts about clouds, those gentle formations of water and air that seem ordinary, yet hold countless hidden wonders. How they form, why they change color, and how they help keep our planet alive. So lie back, relax, and let this voice carry you slowly through a sky of mist and calm. And if you enjoy this journey, don't forget to subscribe to Facts for Sleep, where every video is a quiet dream filled with knowledge and peace. Chapter 1: The Birth of Clouds. From the series 100 Facts About Clouds, Facts for Sleep. If you've ever stared at the sky and thought, wow, that looks fluffy enough to sleep on, you're not alone, and you're also wildly mistaken. Clouds may look soft, but in reality, they are billions of tiny water droplets or ice crystals just floating up there, defying gravity and your common sense. So how did these lazy cotton blobs come to exist? Let's go back, way back, to when Earth was still a hot, bubbling ball of molten chaos. Back then, there were no clouds, no blue sky, not even the concept of weather. The planet was busy burping volcanoes and leaking gases like a teenager's skin leaks oil. Those gases, mostly water vapor, carbon dioxide, and sulfur dioxide, escaped into the airless void and began forming what we now call the atmosphere. When the planet finally cooled down enough, which took, just a few 100 million years, something miraculous happened. Water vapor began to condense. Condensation, by the way. It's the process where gas turns into liquid. It's the same reason your cold drink sweats when you take it out of the fridge. Multiply that by a few trillion tons of water, and voila, you get the first clouds in Earth's history. These early clouds weren't the friendly, sheep-shaped cumulus clouds you see today. Oh no, they were dark, thick, and angry. Think of the sky as a boiling soup of volcanic steam. Scientists call this phase the steam atmosphere, and it basically rained nonstop for thousands of years. If you've ever complained about bad weather, imagine living in a time when the sky literally never stopped leaking. Eventually, all that endless rain filled the first oceans. And from that point onward, clouds became part of Earth's hydrological cycle, the great planetary system that keeps water moving from the ocean to the air, to the land and back again. This cycle, by the way, is powered by sunlight. The sun heats the ocean, water evaporates, rises into the sky, cools, condenses into clouds, and then falls again as rain. It's the ultimate recycling system. And unlike most human inventions, it actually works. Now, here's the fun part. Clouds form because of something called adiabatic cooling. Sounds fancy, right? Don't worry, it's just science for air gets cold when it goes up. When warm, moist air rises, it expands because the pressure up high is lower. Expansion uses energy, and that energy loss makes the air cooler. When it cools enough, the moisture in it condenses into tiny droplets. Congratulations, you've just built a cloud. But what keeps these droplets floating instead of falling straight down like your hopes and dreams on a Monday morning? Size. A typical cloud droplet is only about 0.02 millimeters in diameter. That's 50 times smaller than a raindrop. They're so tiny that air resistance easily holds them up, sort of like dust motes in a sunbeam. Only when they merge and grow large enough do they overcome gravity and fall as rain. Now, let's talk types, because humans love to categorize everything. Clouds, too, were classified by a very patient man named Luke Howard, an English pharmacist and amateur meteorologist who, in 1802, decided the sky needed organizing. He came up with the basic system we still use today. Cumulus, fluffy, cotton ball clouds. Cumulus means heap in Latin. Stratus, flat, layered clouds that look like a blanket. Stratus means spread out. Cirrus, wispy, hair-like clouds found at high altitudes. Cirrus means curl or ringlet. Think of cumulus as the extroverts, stratus as the introverts, and cirrus as the artistic types that hang around. 30,000 feet writing poetry with ice crystals, of course. There are the drama queens of the sky, too. Cumulonimbus clouds, the thunderstorm makers. These towering monsters can grow up to 60,000 feet tall. That's 18 kilometers, and are packed with lightning, hail, and raw energy. If clouds were people, cumulonimbus would be that one friend who shows up late, yells a lot, leaves everything a mess. Clouds don't just look pretty, they're also climate regulators. During the day, they reflect sunlight back into space, keeping the planet cool. At night, they trap heat, keeping things warmer. In other words, they're like Earth's thermal blanket, and sometimes, like all blankets, they make things a little stuffy, and yes, clouds move. In fact, they can travel at speeds of up to 100 miles per hour, 160 kilometers per hour, depending on wind and altitude. So, while you're standing still staring at the sky, that big cotton puff you think is floating lazily might actually be zooming across continents. Now, here's a humbling thought. At any given moment, roughly half of Earth's surface is covered by clouds. Every cloud you see is part of a massive planetary system of vapor, sunlight, and motion, and yet we rarely think about it. We just complain when it rains and take photos when it looks nice. So next time you lie on your back watching clouds drift by, remember, you're not just looking at weather. You're witnessing the visible breath of an entire planet, a living, moving, breathing system that began billions of years ago. When fire met water and chaos learned how to float, and that, my sleepy friend, is how the sky got its pillow. Chapter 2, The Language of the Sky. From the series 100 Facts About Clouds, Facts for Sleep. If the sky were a giant book, clouds would be its handwriting. Messy, emotional, and impossible to read without years of study and a bit of imagination. Every swirl, streak, and puff you see up there is the atmosphere trying to express itself. The problem is, it writes in a language we barely understand. Back in the early 1800s, an English gentleman named Luke Howard decided he'd had enough of people saying, "Oh look, a fluffy one. And that one looks like a dragon eating a pizza." He wanted order. So he did what humans do best. He gave things Latin names and pretended that made him smarter than the weather. Howard divided clouds into three main families: cumulus, stratus, and cirrus, plus a few extended relatives like nimbus and alto. These names sound elegant, but they really just mean heap, layer, curl, and rain. Latin makes everything sound profound, even when you're basically describing cotton in the sky. Let's decode this celestial soap opera, shall we? Cumulus. The show-off cumulus clouds are the ones everyone notices, big, bright, puffy, and shamelessly photogenic. If clouds had social media, these guys would be influencers, posting selfies with filters labeled summer mood. They form when warm air rises and cools, creating upward bubbles of condensation. The top stays white and fluffy, but the base turns gray as it thickens. A moody little reminder that sunshine can turn to rain faster than your last relationship. Scientists describe cumulus clouds as convective, which means they're formed by vertical air movement, basically. The atmosphere burping warm air upward. If these puffs keep growing taller and darker, they can evolve into cumulonimbus, the storm gods of the sky. But we'll save their tantrums for later. Stratus, the introvert stratus, clouds are flat, gray, and cling low to the ground like that one coworker who always wears beige. They're responsible for those endlessly dull days when the entire sky looks like a ceiling that forgot to paint itself, technically. They form when a large mass of moist air gently lifts over cooler air, spreading thinly instead of rising dramatically. It's the atmospheric equivalent of a long sigh. Stratus clouds can become fog if they sink low enough. Yes, fog is literally a cloud at ground level. So the next time you're driving through fog, just know you're basically inside a cloud. Congratulations, you're flying very slowly, cirrus, the artists up high. Where air is thin and freezing, the cirrus clouds dwell. They're made of ice crystals, not water droplets, which is why they look so delicate, like brush strokes of frost across the sky. Cirrus means curl or ringlet in Latin. And these clouds are often shaped by fast winds in the upper atmosphere, creating long, wispy patterns. If you've ever seen one that looks like a horse's tail, you've spotted what meteorologists affectionately call a mare's tail. Cirrus clouds don't bring rain. They're more like mood lighting for the sky. When you see them, it usually means a change in weather is coming, kind of like your cat acting weird before a storm. Altostratus and altocumulus, the middle children, somewhere. Between the extroverts up high and the loners down low, live the middle layers. Alto clouds. Altostratus clouds look like a giant bedsheet stretched across the sky. Uniform, gray, emotionless. They often show up before a storm, announcing rain like an overly polite butler. Altocumulus, on the other hand, form in clumps or ripples, sometimes resembling fish scales, which is why sailors call them a mackerel sky, or subtle, calm and indecisive, not quite high, not quite low, but always beautiful in a don't look too long way. Cumulonimbus, the drama queens. Now we reach the most theatrical member of the family, the cumulonimbus cloud. Picture a colossal tower of vapor rising into the heavens. Anvil-shaped at the top because it hit the tropopause, that invisible ceiling between the troposphere and the stratosphere, and couldn't climb any. Higher, these clouds are powered by violent updrafts, air rising so fast that it drags water droplets miles upward, freezing them into ice before tossing them back down as hail. Inside, there's thunder, lightning, and enough energy to power your entire neighborhood if we only knew how to plug in. Lightning, by the way, is simply nature's way of equalizing electrical charges, a glorified spark plug for the sky. A single bolt can heat the air to 30 degrees Celsius, 54 degrees Fahrenheit. That's hotter than the surface of the sun. So yes, when you hear thunder, you're basically listening to air screaming in pain. The hidden dialects of clouds, of course. There are dialects in this language too, the rare and exotic cloud types that appear like limited edition artwork. Lenticular clouds, lens-shaped, often mistaken for UFOs. Sorry, alien hunters. Mammatus clouds, bubble-like shapes hanging from the sky, named after mama, Latin for breasts. Yes, scientists actually named them boob clouds. Kelvin Helmholtz clouds, shaped like ocean waves, formed when two layers of air move at different speeds. Proof that even the sky has turbulence. Asperitas clouds, dark rolling waves that make the sky look like a troubled sea. Officially recognized by the World Meteorological Organization in 2017 because apparently the sky needed a new kind of drama. Each of these cloud types tells a story about wind speed, humidity, temperature, and the planet's never ending attempt to balance chaos with beauty. When you start seeing clouds this way, not just as decorations, but as signals, conversations, even moods, the sky stops being just the background. It becomes a living diary, written in vapor and sunlight, so next time you look up and see a sky full of patterns, don't just say it's cloudy. You're reading Earth's language, one written not in ink, but in breath. And if you still don't understand what the sky is trying to tell you, well, maybe it just wants you to relax. Take a deep breath and fall asleep. Chapter 3, When Clouds Get Angry.
From the series 100 Facts About Clouds.
Facts for sleep. Every family has that one relative who looks calm, but secretly loves chaos. In the family of clouds, that role belongs to cumulonimbus, the thunderstorm cloud, the diva of the sky. And the main reason your picnic gets canceled 5 minutes after you open the sandwiches? These clouds don't just form, they erupt. What starts as a harmless puff of cumulus on a warm afternoon can, under the right conditions, transform into a 60,000-foot skyscraper of doom. How? It's all about instability, humidity, and lifting the holy trinity of meteorological drama. The recipe for trouble, here's the recipe. Take a large serving of warm, moist air near the surface, usually supplied by your friendly neighborhood ocean. Add a layer of cold, dry air above it. Then, mix vigorously using convection, which is just a fancy way of saying hot air rises because it's lighter. As that warm air ascends, it cools and condenses, forming a small cumulus cloud. But if the atmosphere above is unstable, meaning the temperature drops quickly with altitude, as the air keeps rising, like a balloon that refuses to stop. This is called positive buoyancy, or as I like to call it, cloud caffeine. Soon, the little cumulus swells upward into a towering cumulonimbus. Inside it, updrafts can reach speeds of 100 miles per hour, 160 kilometers per hour basically, hurricane winds in vertical motion. Raindrops and ice particles are tossed up and down like popcorn kernels in a hot pan. The electric personality as this chaos continues. The cloud starts building an electrical charge. Tiny ice crystals bump into larger ones, transferring electrons. The top of the cloud becomes positively charged, and the bottom becomes negatively charged like a giant battery made of water vapor and bad decisions. Eventually, the difference in charge becomes so huge that the air between can't take it anymore. Zap. A lightning bolt slices through, superheating the air to 30 degrees Celsius, 54 degrees Fahrenheit. In less than a millisecond, the sudden expansion of that air creates a shock wave, which you hear as thunder. So next time you hear thunder, remember, you're literally listening to air being violently ripped apart and then snapping back together. It's atmospheric slapstick comedy at 30,000 degrees. The art of precipitation, as droplets and ice chunks bounce around in the storm's updrafts, they grow. Eventually, they get too heavy to stay airborne and begin their descent as rain, hail, or occasionally, either that hurts-sized ice balls. The process that decides whether it rains or hails is beautifully complicated. In many storms, the Bergeron process is at work, named after Tor Bergeron, a Swedish meteorologist who somehow convinced people that frozen clouds were interesting. He discovered that in cold clouds, ice crystals grow at the expense of water droplets. Basically, the vapor prefers to stick to ice rather than water, which is why snowflakes form even when there's liquid water nearby. When those ice crystals grow too heavy, they fall, sometimes melting into rain, sometimes staying solid. Either way, gravity wins. It always does when things really spiral. If conditions are especially dramatic, strong wind shear, moisture and rotation, that towering cumulonimbus can start spinning. That's when we get supercells, parents of tornadoes. Imagine a single thunderstorm powerful enough to create a swirling funnel that can toss cars, flatten barns, and still look majestic in slow-motion documentaries. It's terrifying, but also weirdly elegant, like watching nature's version of ballet, choreographed by destruction. And if you've ever wondered how tornadoes sound up close, don't. They say it's like a freight train. But if you can hear it, you're already way too close. Calm after chaos, after the storm expends its energy, the towering cloud starts to collapse. Rain cools the surface below, stabilizing the air. The thunder quiets, the lightning fades, and sunlight returns, sometimes bending through leftover droplets to form a rainbow, the atmosphere's way of saying, "Sorry about that tantrum." Fun fact, a rainbow isn't actually in the sky. It's an optical illusion, light refracting inside individual raindrops. You never see the same rainbow twice because the droplets move constantly. So yes, you can chase rainbows, but you'll never catch one. A perfect metaphor for adulthood. The bigger picture thunderstorms aren't just noisy distractions. They're vital to the planet's energy system. They transfer heat from the lower atmosphere to the upper layers, helping balance Earth's climate. Without storms, the tropics would boil and the poles would freeze even more than they already do. And inside those flashes of lightning, chemistry happens. Each bolt produces small amounts of ozone. Yes, the same stuff that protects us from ultraviolet radiation. So, in a weird twist of fate, every thunderstorm is also a miniature ozone factory. Destruction and protection, hand in hand, the atmosphere's favorite paradox. So, next time you're lying in bed, listening to thunder rumble in the distance, don't think of it as a nuisance. Think of it as the planet clearing its throat, rebalancing itself, whispering through electricity and rain. And if that's not enough to help you sleep, just remember, somewhere above you, the sky is throwing a spectacular tantrum and still managing to look beautiful doing it. Good night, and may your dreams be storm-free. Chapter 4. The Human Touch, Artificial Clouds, and Sky Experiments. From the series 100 Facts About Clouds, Facts for Sleep at some point in history, humankind looked up at the sky and thought, you know what? We could probably mess with that. And thus began our complicated relationship with clouds, a mixture of curiosity, ambition, and mild arrogance. Because why simply observe the atmosphere when you can tamper with it, right? Contrails sky graffiti-lets start with the easiest human-made cloud, the contrail. You've seen them, those long, white streaks that airplanes leave behind. Some people look at them and think, wow, that's beautiful. Others say it's the government. It's not. Calm down. Contrails, short for condensation trails, form when hot. Moist exhaust from jet engines meets the cold upper atmosphere. When this happens, the water vapor in the exhaust freezes into tiny ice crystals, creating a thin, bright line across the sky. Think of it as a high-altitude steam trail, or, as one scientist put it, accidental art drawn by fuel. The colder and moister the upper atmosphere, the longer the contrail lasts. Sometimes they vanish within minutes. Other times they spread into cirrus-like sheets that hang around for hours, subtly changing the sky's reflectivity. And yes, they do influence climate. Contrails trap heat just like natural clouds, slightly warming the atmosphere at night. Ironically, the temporary flight ban, after September 11, 2001, gave scientists a rare opportunity to study the effect. They found that daily temperature variations in the U.S. widened by about 1 degree Celsius without planes. In other words, even our sky scribbles affect the weather. Ship tracks the ocean's signature now, move from the air to the sea. Ships, those floating factories of exhaust and salt, also leave their mark, quite literally. When massive container ships release aerosol particles, tiny bits of soot and sulfur, those particles act as cloud condensation nuclei, giving water vapor something to cling to. The result? Ship tracks long, bright lines of cloud that trace global shipping routes, like ghostly highways across satellite photos. They're both beautiful and tragic. Beautiful, because they show us how small particles can control vast patterns in the atmosphere. Tragic, because they're also evidence of pollution doing its thing, turning the sky into a chemical experiment. Cloud seeding, the science of playing God lightly, then there's cloud seeding. Humanity's bold attempt to make it rain literally. The idea is simple. Introduce particles into clouds to encourage water droplets to form and grow heavy enough to fall as rain. Common seeding materials include silver iodide, potassium iodide, and sometimes just plain salt. Planes or rockets release these particles into the cloud, where they serve as condensation nuclei, the goal. To kickstart precipitation, cloud seeding has been used to reduce droughts, disperse fog at airports, and even weaken hurricanes, which, to be honest, didn't go so well. Some countries use it regularly. China, for instance, famously seeded clouds before the 2008 Beijing Olympics to clear the sky for the opening ceremony. It worked, but only because the rain politely fell on the next city over. Does it really work? Sometimes, yes. Sometimes, no. The success rate hovers around 30 to 40% depending on humidity, wind, and luck, proving once again that Mother Nature hates being told what to do. Aerosols, volcanoes, and the accidental scientist hears the twist. Humans aren't the only ones experimenting with the sky. The Earth itself does it all the time. When volcanoes erupt, they release sulfate aerosols high into the stratosphere. These particles scatter sunlight, cooling the planet slightly. The 1991 eruption of Mount Pinatubo dropped global temperatures by about 0.6 degrees Celsius. For nearly 2 years, a natural version of what some scientists now call geoengineering. In case you haven't heard, is the idea of deliberately altering the climate to fight global warming. One proposal suggests spraying reflective particles into the atmosphere to mimic volcanic cooling. So yes, we're seriously considering fixing climate change with an artificial volcano. What could possibly go wrong? The hole punch phenomenon, then there's one of the strangest and most accidental human-cloud interactions. The hole punch cloud. Sometimes, When an airplane passes through a supercooled cloud, a cloud made of liquid water below freezing point, it triggers rapid freezing around the wings. This process releases heat, evaporating nearby droplets and leaving behind a circular hole in the cloud layer. From the ground, it looks like the sky has been poked by a cosmic finger. They're stunning, eerie, and surprisingly common near airports. So the next time you see one, don't panic. The sky isn't falling. It's just overreacting to airplanes again. When humans try to heart all of this raises an interesting question. Are we improving nature or just making it more complicated? Because while contrails and seeding might sound harmless, they all feed into Earth's energy balance. More clouds can mean more reflection cooling or more trapped heat warming, depending on where and when they form. It's a delicate equation, one we still don't fully understand. Despite decades of research, in short, the sky is an open experiment and we're all test subjects. The future. Engineering the weather scientists are now exploring AI-driven climate modeling to predict how clouds respond to pollution and temperature. Some even suggest using drones to distribute condensation particles with surgical precision. It sounds like science fiction, but then again, so did flight, lightning rods, and TikTok filters. The truth is, the more we study clouds, the more we realize how little we control them. They are ancient, mysterious, and profoundly indifferent to our plans. We can seed them, pollute them, name them, even imitate them, but we'll never own them. So next time you look up and see a perfect white streak behind a jet, a lens-shaped cloud above a mountain, or a hole punched clean through a gray blanket, remember, you're watching the ongoing conversation between human ambition and atmospheric patience. The sky has always been alive. We just started writing on it. Chapter 5. The Memory of Clouds. From the series 100 Facts About Clouds, Facts for Sleep, if clouds could speak, it'd probably sigh first. They've seen everything, from the birth of the oceans to your 8 a.m. traffic jam, and they've done it all without saying a word. Clouds are the planet's memory foam. They absorb everything. Drift for a while and then let it all go. But let's not get sentimental just yet. We've spent the last 4 chapters turning the sky into a lab, talking about adiabatic cooling, cumulonimbus tantrums, and human-engineered contrails. Now it's time to slow down, look up, realize something strange. Clouds remember more than we think. The sky's memory bank, every droplet of water in a cloud has a story. Some of that vapor was once part of an ocean wave, a melting glacier, or the breath of a dinosaur. Yes, technically, you may have inhaled a molecule once exhaled by a T-Rex. Congratulations, you're part prehistoric. Through the water cycle, these molecules travel endlessly, evaporating, rising, condensing, raining, and starting over. It's nature's never-ending circulation system. Quiet, patient, eternal. But within that cycle, clouds also carry traces of aerosols, dust, salt, smoke, and even pollen. They remember volcanoes that erupted thousands of miles away, fires that burned in distant forests, or desert dust that traveled across entire oceans. The air above you might contain fragments of another continent's past in this way. Clouds are archives of motion, moving museums that never stay still, yet always record what passes through them. The emotion of light of clouds have memories. Then sunlight is the ink that reveals them. Ever noticed how a single sunset can feel like an entire mood? That's not just your poetic imagination, that's physics, photochemistry, and psychology teaming up to make you emotional. When sunlight passes through the atmosphere, shorter blue wavelengths scatter first. That's why the sky looks blue during the day. But when the sun sinks low, light has to travel farther through air, scattering the blues away and leaving behind reds. Oranges and pinks. Clouds catch those colors like canvases, bending and diffusing the light until the sky looks hand-painted. The effect is called Rayleigh scattering, a fancy term for why sunsets look awesome. And when clouds are just right. They can even produce iridescence, pastel shades shimmering like oil on water, caused by diffraction of sunlight through droplets nature. It seems, has been doing impressionist art long before humans ever thought of Monet. The forests above the forests in certain tropical mountains. The air is so moist that clouds descend to the ground and never leave. These are cloud forests, living ecosystems suspended in mist. The trees here drink from the air itself, catching droplets on their leaves. The constant moisture supports an explosion of biodiversity. Orchids, mosses, frogs, birds, all thriving in the perpetual twilight of vapor. But cloud forests are delicate. A slight change in temperature or wind can lift the clouds away, drying the trees and ending the magic. Scientists say that as the climate warms, these forests and their drifting crowns of cloud are climbing higher up the mountains. Searching for cooler air, one day there may be nowhere left to climb. So, when you see a mountaintop wrapped in mist, don't just think pretty. Think temporary. You're witnessing a rare handshake between land and sky. The ancient diaries of air clouds also tell the story of Earth's deep past. By studying ice cores from ancient glaciers, scientists can read trapped air bubbles, fossilized clouds from hundreds of thousands of years ago. This is the science of paleoclimatology, the study of ancient climates. Each layer of ice preserves information about temperature, greenhouse gases, and even volcanic eruptions. It's like reading the planet's diary, except the handwriting is in chemistry, and it's written in frozen time. Through these records, we know how cloud cover shifted across ice ages, how volcanic ash cooled the Earth, and how the balance of sunlight and vapor shaped the climate we now depend on. Clouds are not just passing moods, they are chapters of history, drifting above our heads, rewritten every day, the mirror of ourselves, of course. Clouds aren't only scientific. They're emotional mirrors, one of the few things that look exactly how we feel. When they gather dark and heavy, they echo our worries. When they scatter thin and golden, they match our calm. Children see dragons in them. Poets see longing. Scientists see water vapor. Pilots see turbulence, and somehow they're all right. Maybe that's why humans never stopped looking up. Clouds are the one reminder that even chaos can be soft. They drift. They vanish. They return. Just like thoughts. Just like days, a gentle goodbye. So as we close this journey through 100 facts about clouds, we come full circle from the fiery birth of vapor to the quiet memory of mist. We learned that clouds control our weather, shape our climate, and reflect our emotions. They are both science and poetry, chemistry and comfort. They hold lightning and lullabies in the same breath. And yet, despite centuries of studying them, we still can't predict exactly where one will form, how long it will last, or what shape it will take. That's because clouds, like dreams, exist in the space between control and surrender. So tonight, as you drift towards sleep, think of the sky not as something above you, but as something around you. You are breathing the same air that once floated as cloud, fell as rain, and rose again. You are part of the same endless cycle. And who knows, maybe when you dream, the sky dreams with you. And now, you've reached the end of our quiet journey through the clouds, from their fiery birth in Earth's ancient skies, to the calm drifting giants we watch today. We've traveled through storms, science, sunlight, and silence. We've learned that clouds aren't just weather, they're memory. They hold the breath of oceans, the ashes of volcanoes, the sighs of forests, and sometimes the reflection of our own moods. Clouds remind us that nothing truly disappears. It just changes form. Water into vapor, vapor into rain, rain into life. And maybe, as you listen to these last words, you realize that you too are part of that same endless cycle. So take a deep breath. Let your thoughts rise and drift away, light as mist. And if you haven't already, subscribe to Facts for Sleep, your quiet corner of the internet where science dreams slowly. Because next time, we'll be diving deeper, quite literally, into 50 facts about water. We'll explore the oceans beneath our feet, the molecules that built life, and the paradox of the one substance that can freeze, flow, and boil all within a single heartbeat of the planet. Water connects everything, the clouds above. It's the rain that falls, the rivers that run, and the life that listens. So when this video fades, don't rush to the next thing. Just breathe. Because the next story The story of water begins where this one ends. Good night, dreamer, and may your mind drift gently, like clouds becoming rain.